Hello, everyone, and good evening, good afternoon, and good morning. So, we are here for another crazy day. I'm so sick and tired of people right now, but I'm here because I know a lot of you guys would love to learn how to do certain things and to feel confident in yourselves. So, as promised, someone made a suggestion about graphing linear inequalities. And if we have a little bit of time, I'm going to see if I can do some graphing of factored form. So those were two things that were requested of me. And I said, you know what? Sure. Why not? Why the heck not? All right. So graphing linear inequalities is very, and I keep forgetting, because I have to change my lighting for you guys. Okay. Hello, film artists. All right. So when we're graphing linear inequalities, we have basically two variables. We have an x value and we have a y value. So let's start with y. It's just easier for me to just show you through examples. So we have, I'm going to say y is greater than or equal to 2x minus 5. Now, when we graph these, and I can just do a basic graph. I'm going to do something relatively small here. So when we're graphing, you're going to basically put your inequality in slope-intercept form, which is already there. So now, the negative 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 if we need it. And then just use my dots to help me with my spacing. So you would basically graph an inequality very similar to equation of a line. So the first thing I would have to put in slope-intercept form, which it is, it's very much giving me y equals mx plus b. So my m is going to be my slope. My b is going to be my starting point. So, yeah, it is. So now we always start with our y-intercept. And our y-intercept in this case is negative 5. So as I go to the y-axis, here's my negative 5. I'm going to put my first point. Okay. From here, now I'm looking at my slope. My slope is a positive 2. So anytime it's a whole number, it's really a whole number over 1. Okay. Anytime you see a whole number, it's always going to be over 1. Because 2 divided by 1 will give me my original 2. So from this point of negative 5, I'm going to go up to 1, 2, and over 1, and plot the next point. So my starting point is going to be basically, let's say, my house. And the slope is going to be the directions I'm going to give to get to the next person's house. So I will go up 2 blocks and then make a right, go 1 block to the right. So I can go up 2 blocks and go 1 block to the right. Okay, notice that my points, 1, 2 over 1, 1, 2 over 1. And if you notice, my points is giving me a straight line. And from the left to the right, it's increasing. As my x's are increasing, so are my y's. But this is what makes inequalities different. Now, let me slide over and zoom in to my steps. So first we're going to put them into slope-intercept form, which in this case it already was there. But then here are a couple of rules. When it's less than or greater than, the line you're going to draw is going to be a dashed line. Okay? So less than or greater than is going to be a dashed line. Less than or equal to or greater than or equal to, it's going to be a solid line. Okay, so if it has the line underneath the inequality symbol, you're including those points. So that's why it's a solid line, because you have that sense of inclusion. Now, in our case, let me take a flashback. We have y is greater than or equal to. So since it's greater than or equal to, that means I'm drawing a solid line. So from here to here, it's going to be a nice, long, solid line. Okay. So that's one step. Now, the next step, we're going to do what's called shading. Now, it's not the shading that we do like, oh, look at the outfit. Oh, yeah, that's a cute little outfit. She looks crazy. Not that type of shade, okay? So instead of you picking out points, because the whole premise of all this is you want to figure out what set of points on that graph, okay? What set of points on this graph is going to make this inequality a true statement. Okay, that's the reason why you're doing inequalities. Now, if you want to, you can pick points either on this side of what's called the boundary line. That's the line that we drew, the green line. So it's either you have points that's going to satisfy this side of the boundary line, or it's going to be points that satisfy this side of the boundary line. Okay, now when you do this, and this is me, maybe I'm lazy. I don't want to have to pick each and every single solitary point that's going to satisfy that. Instead of doing each and every single solitary point, you do what's called shading. So the shading the area, roughly what side of the boundary line is going to give me my true statements. So one of the ways is I like to say, if it is greater than or greater than or equal to, you usually shade the top portion of it. If it was less than or equal to, you would shade the bottom portion. But what happens if you look at your line and you're like, dude, I have no idea which one's top or bottom? So many jokes that pops in mind. I'm just going to keep it to myself. All right. So in the way that you can tell which side you should shade, yeah, I almost slipped up, is you want to test it. Let me go back to my notes. You want to test it with that 0, 0. Okay? It's easy to plug in zeros for the x and zeros for the y, and you'll get your answers so much quicker. So most of the time, 0, 0 is either on one side of the boundary line or the other. In this case, here's my 0, 0 right smack in here. So the way that I can test it is I'm going to put it over here. I'm going to see if I can unzoom just a little bit. I'm going to write the word test. And we're going to test with 0, 0. So I'm going to take my inequality. I'm going to plug 0 for the y, and I'm going to plug 0 for the x. So I got 0 is greater than or equal to 2 times 0 minus 5. 2 times 0 will give me 0. So that means I have 0 is less than or equal to 0 minus 5. So now I have 0 minus 5. That gives me a negative 5. So we have 0 is greater than or equal to negative 5. So you need to ask yourself, is that answer a true statement or a false statement? And the only way you can tell is go back to the number line. Okay, so say 0 is here. -5 will be on the left-hand side. So we all know when you go to the left, you're going all the way to -infinity. So this is where your lower numbers are. If you go to the right, you're going to positive infinity. This is where your larger numbers are. So -5 is closer to -infinity. It's going in that direction. So -5 is lower than 0. Think about it. It's losing $5 is worse than just don't have any money at all. Okay? So this is a true statement. Because 0 is larger than -5. Now, since it is a true statement, they're saying that all these points on this side of the boundary line makes it a true statement. So this point makes it a true statement. This point over here makes it a true statement. This point over here. This point right here. This point right here. You see how freaking crazy this is? Right? So instead of us picking each and every single solitary point, and even the points that are in between, we do what's called shading. So we take maybe a highlighter, if you have it. I love to do highlighters when it comes to this. I just do a little light shading. Okay? So I'm saying every single solitary point on this side of the boundary line is going to give me a true statement. Okay? If you don't believe me, all right, let me try. Let's say -30, which is right smack here where my finger is. So my x value is -3. So 2 times -3, that gives me a -6. -6 minus 5 is a -11. So I have 0, because that's the 0 of the y value here. 0 is greater than -11. Is that a true statement? You bet your Aunt Susie it is. It is definitely a true statement. Right? I know. As soon as I made that weird comment, I was like, don't look at the comments. Don't look at the comments. All right. I'm learning this in math. Good. Huh? All right. Okay. So we're already finished Unit 6. Okay. Good job. All right. So let me backtrack because I kind of left you in lurch. All right. So yes. Perfect timing. I have an exam on this Thursday. Awesome. Okay. Never seen it like that. Okay. Up over 1. Yes. Oh my God. Rise over run. Yes. 2 over 1, yes. Good job. All right, I'm on top. Okay, your explanation is great. Awesome. Just got done with differential equations. Good job, Chaser. Okay, so do I graduate now? You can graduate and walk whenever you want to, darling. It's up to you, okay? So this is basically what you're doing. You're trying to find, 1, where should you put your boundary line? Okay. 2, which side of the boundary line is going to satisfy this inequality? All right. And then you just have to make sure you know what type of boundary line you need to draw. All right. So let's try another one. Let's do this one. Okay. Let me see if I can get this in here. All right, so we have y. Looks like I gotta get myself new Sharpie pens. 2x plus 5. Okay. All right. Well, I'm not. Here we go. So we got y is greater than -1/2 x plus 5. All right, so 1, we're not freaking out. Because I know you guys, you're probably like, oh my God, there's a fraction. I'm about to lose my mind. No, you're not. You are not allowed. Where did my blessed ruler go? Okay, all right. I wanted to keep it legit and do a ruler, but I don't know what I did with it. All right. So here we are. I know I got a positive 5, but I'm going downwards. So I can go here, and I can come to about here. Okay. Hey, when you can't find a ruler, use a pencil. And this is why I love doing my dots. Because all I have to do is draw right through my dots, and I'll be ready to rock and roll. Okay, so this is my y-axis, this is my x-axis. Okay, so first thing, my inequality is in slope-intercept form. It's y mx plus b. Awesome. So my b is always going to be my starting point. That's my constant. So I am putting the first point where my y-axis, starting at the origin, where my y is equal to 5, which is right smack here. So from this point, I'm looking at my slope. So this looks similar to just a regular equation on line. So from this point, I'm dealing with my slope. And remember, slope is your rise over your run. So my rise is a -1 and my run is 2. Or I can say my rise, I'm going to write the word or. I could say my rise is 1 and my run is -2. Okay, that's the cool thing about negatives, okay, negative slopes. You pick which one is going to be negative, not both, just one. So starting from my y-intercept, I can go basically down 1, because that's my rise, and over to the right 2 to make my point. Okay, so I'm going to go down 1 to the right 2. Or if I start at my y-intercept, I can go up 1, because it's a positive 1, and over to the left 2. Okay, up 1, over to the left 2. Because notice those 2 points are still on that same line. Okay. All right, good. So yes, thank you for the corrections. But if I go up first, then I will go to the left. Yes. If you're going down first, you will go to the right. Yes. There you go. Because my rise was negative. If I went down, that means my run is going to be positive. I'm going to the right. If my rise was positive, I'm going up. If my run is negative, I'm going to the left. But this instance, right? When it comes to slopes, you have to decide which one is going to be negative. Okay, Bridget, you just have to figure out which one is going to be negative. All right, so if you're figuring that, okay, a lot of people normally just make the numerator, which is the top, negative. If you want to do that each and every time, awesome. But there are going to be times that the graph is not going to give that to you. Like if I made this graph a little bit smaller, sometimes I would have to go up and to the left. So it will kind of depend on the situation. Okay, what do you do with the +5? Well, the +5 is where we started. We started, and that's your y-intercept. Let me change colors here. Your y-intercept is also known as your starting point. So if they say an initial amount, or if they say a starting distance, or they say a starting height, or the candle was at this height, anything initially or what you start with, that's always going to be your y-intercept. All right. So with that being said, we have, basically we can see the line. Okay, we can see that. But now we have to figure out, no, seriously, where did my thing go? 1 minute I had a ruler, next minute it went poof. Goodbye. I don't know. I'll find it as soon as I turn the lights on because, oh, there it is. All right. But now we need to take, before you start drawing any lines, this is inequalities. You need to start looking at your inequality. Once you get your points and you found the rhythm of your points, now you need to look at your inequality. My inequality is greater than. It doesn't have a line underneath. So because it doesn't have a line underneath, I am doing a dashed line. Just draw up, draw up, draw up, draw up, draw up. Okay? Nicely dashed. Okay, so you're not including the points that's on that line. Okay, hence the dashed. This is Algebra 1. So this is like second semester Algebra 1. Okay. You could just find the x-intercepts on the x-axis and then connect the 2 points. Yes, you could. Yes, you could. All right. So now we need to figure out which way we're going to shade. Are we going to shade above or are we going to shade below? If you can't see it yet, it's okay. All right, if you can't see it yet, this is why we're going to test it with this point 0, 0. So we want to know which way we're going to shade. After a while, you'll figure out which is going to be top and which is going to be bottom based on how your boundary line is angled. Okay? But if you're not sure, let's test it with that point 0, 0. So we're using our inequality. Let me see if I unzoom just a hair. We're using that inequality. We're going to plug a 0 for the y, and we're going to plug a 0 for the x. So now, anything times 0 will be 0. So that means -1/2 times 0 is equal to 0. 0 plus 5 will give me 5. So, is this a true statement? 5 is greater than 5. Is this a true statement? Yes or no? Put it in the chat. Hey, a girl named Eric. Okay. So we gotta know, is this calculus? Diego, you know this isn't calculus. You've been here before. So lovely to see you again. All right, no, and no, okay? So the side that contains, the side of the boundary line that contains that point 0, 0 is not going to be shaded. That means it's going to be the side that is away from 0, 0. Now, if you don't have a highlighter, you can use a pencil, okay? I like using the highlighters, especially when we do a system of inequalities, which I'm going to do not tonight. But when it comes to a system of inequalities, it's always nice to have a yellow highlighter and a light blue highlighter, because yellow and blue makes green. And then you can actually see where the two types of shades overlap. So you won't have to guesstimate when it comes to like dealing with just with pencils. But when you're just graphing linear inequalities, you have one boundary line and then you have to figure out which way or which side you're going to shade, as well as what type of line you're going to draw. Trust me, this is why you should do it in pencil, because you're going to forget. You're so used to drawing lines because you've been graphing linear equations forever. And then you're drawing lines, right? And then all of a sudden you're like, oh shoot, I forgot, it should be dashed. And then you're trying to erase. If you ever do it in pen, just write the word dashed and draw an arrow, okay? Most teachers will understand because we all know everyone goes through that. If you go the opposite rise direction or either, then you also go the opposite run direction. Correct. So like if I start here at 5, if I went up 1, that means I have to go to the left 2. As opposed to when I go down 1, I would go to the right 2. Okay. All right. Awesome. So good. I'm so glad you guys are helping each other out. That's awesome. Hello, Jocelyn. Okay. Hello, Michael. I don't think I said hi to you earlier. I'm sorry. All right. So let's do another one. Okay, let's do another one. Actually, let's do 2 more. And we'll see how things go. All right. I'm not sure if it's going to fit on my grid, but we're going to give it a try. See if I can raise it up a little bit. And the reason why I'm saying that is because I want to do, here's my example, I want to do 2x plus 6y is less than or equal to 18. Okay, just learning. Oh, good. All right. Ooh, this looks different, don't it? Here goes Audrey doing all some different stuff. It's just like a teacher, you know, like we teach it to you one way and then all of a sudden you get the homework problems and it looks nothing like what we were doing in class. I know. Yeah. All right, 6 on the y-intercept. Okay. How did you get 6? Is it Nurek? Or Karen backwards, spelled backwards? How fun is that? I think I figured it out. Because it's next to y. Okay. So, but is this in slope-intercept form? Because some people are mentioning some things. Some people are saying subtracting the 2x from both sides, not the 2y. Oh yeah, there was a correction. Okay. So we're dividing both sides by 6. Okay. So I was like, oh, I think I figured it out. I was like, wait, that's Karen spelled backwards. That's awesome. I know. Now, we have to put this in that slope-intercept form. Okay, so remember, slope-intercept form is y equals mx plus b. That means y is by itself. Right now, y is not by itself. It's like a whole party right here. Okay, so we need to isolate. So we want to get this 6y by itself. So would it be okay to simplify? Yes. So this is what we're going to do. We're going to subtract that 2x on both sides. Yeah, Tatiana, I see you, girl. I see you. But some people, it takes a little extra time for them to process. So that's the one thing that I do over here. I take my time. So when I subtract 2x on both sides, I got 18 minus 2x. But if I do 18 minus 2x, It's not in that same format. And this what gets students all the time. So put it in that format. Put that minus 2x here, and since that's a positive 18, put that plus 18. Now, if you said 18 minus 2x, that's fine. That's fine. But as long as you know that eventually your slope is going to be the coefficient of the x, and your y-intercept is going to be the constant, that's all you need to know. All right? So now we need to get y by itself. So that means we have to divide everything by 6. A lot of people like to make one big line right here and just put 1 6 down. But then they would divide the -2 and the 6, but they'll forget to divide the 18. So that's why I just like to put the 6 underneath all 3 terms. Okay. I don't want to say this is for freshman year because I know some 7th graders that are doing Algebra 1. I know 8th graders are doing Algebra 1, 9th graders. I actually know some 10th and juniors that are doing Algebra 1. The struggle is real. The struggle is real. So it could be anything. It could be pre-algebra, it could be Algebra 1. So now let's divide. 6 divided by 6, that will give me my 1y. Yay, that's what we're looking for. Then we have our -2/6. That can be simplified. So -2/6, it's still going to be negative. But if I divide the 2 and the 6, or just basically simplify it by 2, I'm going to get 1/3 x. Because 2 divided by 2, or -2 divided by 2 will give me -1. 6 divided by 2 will give me 3. So that's how you reduce 2/6 to -1/3. Plus 18 divided by 6, that will give me 3. All right. Okay. I get you, Jocelyn. I know, it's like trying to figure it all out. Hey, Brandon. All right, so now inequalities is another thing with solving. When you multiply or divide by a negative, that's when you have to change the sign of the inequality symbol. I know there's so much to remember, but we divided by a +6. So we're lucky that we do not have to change the inequality sign. Okay? So yeah, you got to worry about what type of lines you're going to draw. You got to worry about when you're solving it, if you have to flip the inequality sign. You got to worry about the shading. Yeah, it's a lot. It's a lot with inequalities. Okay? All right? Yes. So when you multiply and divide by a negative, you switch the inequality sign. Not just because we got a product. See, when we simplify the -2/6, that's not what I mean. I'm talking about this section. Let me see if I can get something. Use this pink right here. So I'm talking about this section right here. When we divide by the +6, the inequality sign does not change. It's only when we divide, or if we had a fraction, we had to multiply everything by a negative number. That's when it changes. Okay. I know, right? It's like we're all bringing it on back. Okay. So now, let me slide a little bit. So we have, I'm going to make my graph right here. So we can make it not too crazy. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just want you to see how easy it is to make your own graphs. Now, if I had a regular notebook, this graph would be wonky as I don't know what. Now I can actually see the consistency. All right, why wouldn't the -2, 6 just be -3? Because you're not dividing a +6 by -2. You're dividing -2 divided by 6. So if that 6 was in the numerator, and the -2 is in the denominator, yes, it will be -3. Okay? Anytime your numerator is smaller than your denominator, you're reducing. But when your numerator is larger than your denominator, you're dividing. Okay? Hey, Dolly. All right, so should be +3 on the y-axis. Thank you, Brandon. Reading my mind. 1, 2, 3. So right here, that's a dangerous thing, Brandon. I just want to warn you. Because some of the things that this mind just conjures up, good Lord, I should have been arrested years ago. Anyway. So y-intercept, this is where we start. First point goes on here, starting at 0. I can just simply go up 1, 2, 3, draw my point. Now from here, I'm looking at my slope. So my slope, let's make it a little bit bigger for the senior seasoned people, including myself. So we have -1/3. Remember, your numerator is your rise. If we're going to go down 1, that means we're going to the right 1, 2, 3. Okay, down 1, 1, 2, 3. Okay, you only count once you move. So you're not starting at a point and say 1 and then you're doing 2, 3. No, when you move down 1 and then you count 1, 2, 3. All right, down, that's 1. 1, 2, 3. Now, if I want to, I can go the opposite. So if I'm going up 1, I'm going to the left. 1, 2, 3, making my point. Go up 1, 1, 2, 3, making my point. Now I see the products, or the possibility of a beautiful line. Now, all right, so what type of line am I going to draw? I think I said lime instead of line. That's how my day is, like crazy. I don't know if I'm having a stroke or what. I have no idea, but I need to calm it down. So, what type of line am I going to draw? Is it going to be a solid or is it going to be a dashed? Yes, it is going to be a full line, but when I think of full line, there we go. Thank you. Solid side. What did I miss? Well, right now we're doing graphing linear inequalities. So yes, solid, solid. Awesome. And the reason why it's a solid line, what's the key? What's the key? What's telling you it's supposed to be a solid line? Yes, less than or equal to. It's the equal to piece. Yes. Okay, so it's that less than or equal to. Anytime it has a line underneath the inequality, that means you're including it, okay? You're equal to it. All right, lovely. So, are you doing graphic quadratic functions in standard form? How'd you know I was going to do that next? Yes, I am. I will be doing that next. Someone asked me for factor form as well. So I'll see if I can do that as well, because I do have it set up. If not, I'll do that tomorrow. And if you can't see me tomorrow, what time am I going? Tomorrow is what? Wednesday? Oh, I don't do tomorrow. I do Thursday. Sorry. I think. My schedules are all kinds of mixed up. All I know is I got students like there's no tomorrow. Nope, I'm doing 1 o'clock. So I'll be here 1 o'clock tomorrow. And if you can't see me, there will be a replay. Now, we got our line. Which way are we going to shade? Are we going to shade above or are you going to shade below? How I know it's above, the way it's being angled, and it seems like it's going all the way up to positive infinity. This one is covering everything down, so mostly down all the way to negative infinity, and it's based off of the y-axis. So which way should I shade? Above or below? Okay, Bridget says below. Okay. Yes, please. Do we have to plug in 0 to find that out? We can. We can. Oh, hello, Michael. There's a lot of Michaels tonight. Okay, Michael's saying above. Karen's saying 0 for the x. 0 for the x and the y, Karen. For the x and the y. Okay, so I got a couple for below. I had a couple for above. I also take question marks so I can get the notes in a moment. Below because it's negative, and then saying above. Ooh, I gotta fight to the death here. All right, well, let's take a look at it. So we have, oops. If I plug in, remember we have to test it. So if I test, I'm just going to put it here. So if I test, we're always using 0, 0. Because as you can see, 0, 0 is on one side of the boundary line. So now I'm going to plug in a 0 for the y. Oops. Negative 1/3. And a 0 for the x. So if we have 0 is less than or equal to 0 plus 3, that means we have 0 is less than or equal to 3. Is this a true statement? Okay. All right, so this is a true statement. Yes. So since it's a true statement, you want to shade the side that contains that point 0, 0. So basically anything from here on down is going to be a true statement. I know 0 doesn't equal 3. Okay? It doesn't equal. It's less than or equal to. That's what this is really actually saying. A lot of people think it's less than or equal to and equal to. It's not and. It's less than or equal to. That's the correct pronunciation. Yes. Thank you, Bridget. Okay. Hello, Tiffany. All right. All right. So that's basically how we're shading it. So if it's not, all right, nice. If it's not in slope-intercept form, we have to put it in slope-intercept form. So we have to solve it for y. Once we do that, we go ahead, plot our points. Starting point is the y-intercept. Our slope is telling us where to go for the next point. Then we have to stop and take a look. Is it a solid or a dashed line? Which in this case it was solid because it's equal to, okay? And then we had to either test it, or if you notice, if it's less than, we shade below. If it's greater than, we shade above. Okay, this was greater than, and this is greater than because it's tilted this way. This will be the top side because it's going up to positive infinity. This one is going down to negative infinity. And you shade above. Okay, so eventually you won't need to test. Okay, so eventually you won't need to test. You would just have to look at the inequality to figure out which side of the boundary line you're going to shade. All right. Oh, well, hello. Is that my girl, Ruth? Hey, Tiffany. How are you? All right. Okay, so let me create a scenario for you to do. And then we'll make sure that we're on the right page. And then we're going to see if we can get ourselves graphing some quadratics. All right. Okay. All right. So here we go. So this is just starting to get a little... Okay. So let's do this one. Negative 12x plus 3y is less than negative 9. Okay. So negative 12x plus 3y is less than negative 9. Okay, so don't give me any directions. Okay, I'm okay. All right, so I want you to do this on your own. And probably about maybe 2 minutes, we're going to go over it. Okay? All right, so in about 2 minutes, we're going to go over it. So do the whole thing yourselves. In about 2 minutes, we're going to go over it. So honeycomb, we don't have any like terms. Okay, good job, Ruth. Proud of you. Keep practicing. Check it again, Karen. Take your time. Oh, not a problem, Ruth. Oh, that's good. Glad to help. Okay. Bridget. You're getting the stink eye from the teacher. Just hold on. Okay. Just hold on. You know that look. But I'm glad that you're getting it, though. Right. Can you send it? I know, 4 minutes ago. Brandon. Jeez. All right, guys, go ahead. Show me your inequalities as best you can. Okay. Because I know some of you guys are on your phones. It's kind of hard to put the symbols up there. But, tell me what your inequality is. Tell me what type of line you're going to draw. And if you're going to shade above or below. Okay. Well, hello, Melissa. Go ahead, Brandon. Show your work. Hello, Drew. Okay. Right. On it and below. Good. Nice, Michael. Okay. And remember, question marks are acceptable as well. And I'll keep going. Maybe this is what I need to do, something funky for subscribers. I think that's what that'll be my next step in this whole TikTok phase. Possibly get a subscription and just actually put something up that has like Squid Games on there. Because remember, this is not Squid Games. You're not going to die if you get the wrong answer. That's how we learn from each other. And we actually have people on here that are willing to help other people out, that's what I really love about you guys. All right, awesome. Thank you. All right, thank you for your honesty. Okay, so we have like Jocelyn with the less than. Okay, dotted and shaded. And the underside, okay. All right. Okay, I'm the real bear too. Hello. All right, so taking a closer look. Let's go. So first thing, we need to put this in slope-intercept form. So I'm going to try to do the work over here. So we have negative 12x, okay, plus 3y, all right, is less than negative 9. So now, let me zoom in so you guys can see this. So we want to get y by itself. So we're going to add the 12x on both sides. Okay, just like you would for a linear equation. The 12x's are going to cancel out, leaving me with my 3y is less than. And since I want to slope-intercept form, I like to put the 12x first, and then the minus 9 comes down. If you say negative 9 plus 12x, that's perfectly fine too. Okay, don't let anybody tell you anything different. So now I want to get the y by itself. So I'm going to divide all three terms by 3. And since it's a positive 3, that means this inequality is going to keep the same direction. So I have y is less than 12x divided by 3 gives me 4x. And negative 9 divided by 3 gives me negative 3. So this would be my inequality. Y is less than 4x minus 3. All right, thank you. So now, do we understand how I got that? I think pretty, since you came a little bit later. Did you see how I got that part? Okay, all right, and Karen sees that. Okay. Okay. How is it 4? 12 divided by 3 will give us 4. Okay. Yeah, that's a 12. Oh, no, it's a 12. Okay. So could it be y is less than negative 3 plus x? Not plus x, but plus 4x. Because 12 divided by 3 gives me 4. Yes. Thank you, Bridget. If you put the 4x there, that'll be fine. When we move 12, we divide it by 9. Oh, no. No, because when you're solving an equation or even inequalities, you always want to solve for y. Okay? You don't want to move your constants over to the y side. No, you want to isolate this variable as best you can. All right? So, first part, where we're starting. We're going to start at negative 3. That's my y-intercept. That's my constant. So here's negative 1, negative 2, negative 3. So I'm going to put a point on negative 3. So that's my starter. So now from here, I'm going to look at my slope. Anytime my slope, you see a whole number, you always put it over 1. Okay? Because it doesn't mess with the value of the slope. So anytime you see a whole number, think of it. 4 divided by 1 still gives me 4. So I still have that value of 4 being represented. But slope always is a fraction, rise over run. So I'm going to, from my starting point, rise up 4 and then go to the right 1 to make my next point. So go up 4, 1, 2, 3, 4, over to the right 1. Okay. If I wanted to go double negatives, I can. Because remember, a negative divided by a negative is a positive. So if I want to, I could go down 4, 1, 2, 3, 4, but over to the left 1. Okay, that's an option as well. Notice, it's basically nice and sweet in that line. Okay. So now I go to my inequality before I start drawing anything. So when I go to my inequalities, I notice it is less than. It's not less than or equal to, it's just less than. So that means I'm doing a dashed line. Okay, so I got my dashed line. And then most of you guys said, where am I shading? I have shading the underside, shade below, shade below. I think everyone said shade below. Okay, so I had like 4 people that said shade below. So if you're not sure which one's above and below, let's test it. Let's test it out with this 0, 0. Okay, so when I test it, I'm going to put it, I think I'll put it over here. So if I test it, I'm going to test with the 0, 0. So that means I'm going to plug 0 for the x and for the y. So if I do that, negative 12 times 0, that's going to give me 0. So let me write it so I won't, let me not be lazy and actually show the situation. So negative 12 times 0 is 0. 3 times 0 is 0. So that means I got 0 is less than negative 9. Is that a true statement? Shade below to the left. Okay. So is 0 smaller, less than negative 9? Yay or nay? Think about the number line. Think about your pockets. Okay, losing $9 compared to don't have money at all. Okay, losing $9 is less than no money at all. It kills you even more, especially when you're trying to reach in your pocket and you're like, and dust in the wind. All we are is dust in the wind. There we go. All right. All right, so 0 is not less than. So this is false. 0 is greater than negative 9. Okay, it's greater than. So that means the side that needs to be shaded is below this line. So all the points in that shaded area is going to make our original inequality a true statement. Okay. So negative 9 is definitely less than 0. Thus so false. Yes. Okay. All right, good. All right. How are we feeling? Okay. Tap away if you want. Get our true 19 here. So if you know of anyone that's probably taking a class, maybe one of those intermediate math classes, or if you know someone that's getting their GED or the ACCUPLACER or ASVAB, and they need a little help with the algebra component, go ahead and share the live. You know, share it, tap it. Tell them about me so they can come. Maybe they might not come tonight, but they might be able to do for tomorrow. So many jokes there. I'm just so tired right now. But this is basically the whole premise when it comes to the whole inequalities. Okay, so when it comes to inequalities, again, we'll try to, bless it. I love how TikTok's like, are you still here? Yeah. All right. I'm like, do you not see people tapping like crazy maniacs? All right, so there we go. So it's just like when we're looking at our steps here. Okay? So we have to put the inequality in slope-intercept form. Once we do that, go ahead and plot your points. Then you take a look at what are your lines. Are you going to do a solid line or are you going to do a dashed line? Then you look at the inequality again. If you're doing greater than or greater than or equal to, or less than or equal to, the top one you're going to shade above. The less than or equal to, you're going to shade below. But if you're not sure, test it with 0, 0. Okay? You want to basically shade the side that gives that original inequality a true statement. All right? Okay. All right. So that was graphing linear inequalities. Okay? So as promised, I want to That was factor form, but I'm going to do factor form tomorrow. All right, so I'm going to do this one. I have 4 examples. So that was graphing inequalities. Now this might be a little advanced for some people, but I'm going to put it out there and let's see if we can kind of follow along. Because now we got something called graphing quadratic functions. Now, linear functions, they give us a straight line. Quadratics give us a U-shape, and this U-shape is called a parabola. Some people say parabola, but it's called a parabola. Okay? So the parabola opens one of 2 ways. It opens either up like a cup, or if I rotate it this way, or it can open down like a frown. Okay? When it opens up like a cup, it's positive. Think like you're smiling, right? Okay? When it opens up like a cup, it's like a smiley face. Little creepy smiley face, but still a smiley face nonetheless. But when it opens down like a frown. Okay? Really sad. Like mega sad. Now, there are certain things that you need in order for you to figure out how you're going to find what's called the vertex. Now, the vertex is your, what they like to call your turning point. Okay? So it's your turning point. Notice, if I start over here, the graph was going down, 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 down. Then it hit a point, and then it started going up. Okay? The point that it hit when it changed direction is called your vertex. Okay? So we can find this vertex one of many ways, but right now for tonight, I'm doing just labeling. Okay? We can calculate how to find all these things later. I just want to hit on just the labeling piece. Okay? So when your vertex is down below, that means this is the lowest point. So since it's the lowest point, this is called your minimum. Okay? So think of my life, right? I just went through a divorce. It'll actually the anniversary of that. Yeah, let's celebrate that, right? Is coming Saturday. That's fun. So things are just going down and down and down, and just ridiculous, right? Then you finally, after you did your court, you filed all your paperwork, did all that, and then all of a sudden, you start building yourself up. Okay? You got down to your lowest point. You're just like, I don't know what I'm going to do. I don't know what's going to happen. I don't thank God I don't have any children. This is a bit of a disaster, blah, blah, blah. But then you build yourself back up, right? You start going to church. Start going to the gym. Just have to go to the gym more consistently. One day just said, screw it. I want cookies. So I just ate cookies. Some people go out to, wine bars and everything like that. I stopped drinking. So I don't know. That's weird. But yet it kept going up. All right. But when you have, if I may flip this around, maybe it's one of those situations that, hey, life was going great. And then all of a sudden it stopped and it just went, just completely going downwards. What's going on? My car stopped working. Someone robbed me. All of a sudden my microwave's not working. All of a sudden the hot water heater decided to go off. I look around and all I can find is left-footed shoes. Like, where's the right foot? No one knows. All of a sudden it disappears. You know, all of a sudden you feel like your sanity's slipping away from you. All right, something like that. But anyway, but then this turns out, if it's opening downwards, that this turns out to be your maximum. Okay, that's your highest point. It's still your vertex because that's the point where it turned and changed direction. But when I was going up and then it hit a point and then I start going down again. All right. So if it opens up like a cup, you have a minimum. If it opens down like a frown, you have a maximum. Okay. Right. So yes, good. All right, awesome. So someone mentioned symmetry. Yes, there is symmetry. Okay, so where can I use? Oh, grab this piece of paper. So if I cover up, oops, so sorry. If I cover up half of my parabola, this side looks exactly like, I feel like I'm doing a tattoo or something. Thank God I'm not. Okay, so this side looks similar or exactly like this side. It has symmetry. It's almost like there is a line that goes right through and splits your parabola in half. That is called the AOS, the axis of symmetry. Okay? The axis meaning line, symmetry, split into two equal parts. Okay? There is a formula for it, but we're not going to do that tonight. We're just going to do location. All right? But the axis of symmetry, notice there's two equations. One of them says x equals h. So if I go up to vertex, vertex is my turning point. Notice the x value is h. So they don't want to use x and y because that's part of the equation, right? Remember that y equals mx plus b thing? Yeah. But since we're looking at quadratics, it's a different equation, but they still use x and y's. So that's why they're using h and k. K meaning your constant. All right? I didn't invent this. I just know how to break it down. All right? So if you notice, your axis of symmetry, everybody wants me now. Okay? Your axis of symmetry goes right through the x value of your vertex. So if you ever get stuck and you're like, oh God, I can't remember the formula. But if you see the vertex and they say, what's the axis of symmetry? Let's see. You're just going to give the x value of your vertex. Okay, that's that green line. That's called the axis of symmetry. Or some people just say AOS. Okay. All right. So let me answer the first 3 questions off of this. Okay. So my vertex, as a couple of you guys already put up, that's that turning point. Our vertex is an ordered pair. That's 0, 0, because it's right at the origin. Now, since it's opening up like a cup, this is going to be a minimum. I'm lazy, so I usually circle when they give me the option like this. And then the axis of symmetry, it is a line. Basically, it's the y-axis, but it's crossing because it always says x equals. Okay, the axis of symmetry always starts at x equals. It's the x value. And the x value of our vertex is 0. All right. How are we doing so far? Because I know we switched the script. We went with Algebra 1. We're still doing that script. We went with Algebra 1. We're still doing Algebra 1, but a little more advanced. Algebra 1 / preparing for Algebra 2. Ah. Ah. That was weird. Okay. I'm just looking at myself on my computer. I'm like, why all of a sudden the screen went dark? Okay. All right. So now, here's a secret. Are you ready? Domain. And I think we talked about domains before. Domains are the list of your x's. Okay? So it's the list of your x's. So your domain is like, if I went to 1, I can go up and I found a point on that graph. If I go to 2, I can go up. And eventually, it's a little bit off, but I could go to a point on that graph. If I wanted to go to 0.5, I can go and hit a part on that graph. And same thing happens with the negatives. Okay? We're only seeing a small snapshot of this graph. This graph is going to keep going up and up and up and up and out and out and out and out. So it's going to cover not just a couple of x's, it's going to cover a lot of them. In fact, it's going to cover all of them. So your domain for all quadratic functions never changes. It's all real numbers. Okay? You can write out all real numbers. There is a symbol. If you draw 2 sticks, draw a capital P, but make it into an R. Okay? 2 sticks with a capital R around it. That's the symbol for all real numbers. And then I think some people like to do interval notation. So they say from -infinity to +infinity. So all those means the exact same thing. All real numbers. Okay? Okay. I could, but not tonight. Can you do trigonometry? I can, but not tonight. All right. So, your range, just as your axis is symmetry, you can take from your vertex. Your range, you can also borrow from your vertex. Okay? So, if you look, my range, that's my y's, the list of my y's. So notice the graph stops here at 0, 0. It doesn't come below my x-axis. It's only from when my x-axis is at 0, and it goes all the way to +infinity. Because remember, it's going to keep growing up and spanning out. We're only seeing a small snapshot of it. So my range, I can make an inequality of this. I can say my range is y is greater than, okay, because it's opening up and it's looking at numbers that are larger at 0 and larger. The reason why I know it's at 0, because that's my vertex. So I can take the y value of my vertex to help me with my range. And since it's including that point, it's not a dashed line, it's a solid line. So it should be greater than or equal to 0. Okay. How are we feeling? Yep. So -infinity to +infinity, that's for the domain. Is this Algebra 1? Yes, it is. Algebra 1, a little bit of Algebra 2. Okay. All right. So your vertex can help you out with two things. It can help you out with the axis of symmetry. That's the x-axis. And the y-axis can help you with your range. All right. Now, last bit. Close to the last bits. How many x-intercepts? How many times is this graph crossing or touching the x-axis? The x-axis. How many times? Put it in the chat. Hey, Amber. Lovely to see you. Hopefully you're doing okay. All right, so Silver saying 1. Alastair's right saying 1. Okay, Melissa saying 0. How do you get the sign for the range? Well, if we take a look, it's not dealing with any negative. It's going to be a solid, since it's a solid line for my parabola. So that's going to be equal to. And since it is dealing with numbers for the y-axis, as it's increasing all the way up to positive infinity, it's going to be greater than. Okay, because it's not dealing with negative numbers at all. It's only dealing with positive numbers on the y-axis. So that's why it's going to be greater than. And it's equal to because it's a solid line that's drawn. Okay. So, how many times is this graph crossing the x-axis or touching it? It's touching it right here, right at the origin. So we have 1 x-intercept. Okay? Just 1. How many times is it crossing the y-axis? Same thing. 1. And it's both happening at that same point, which is at 0, 0. Okay. How are we feeling? Okay. How are we feeling, guys? Now, some people, you probably haven't seen this since you were a fetus, right? So it's been a minute. So if you're just like, it's okay. It's all right. We do not need for you to blow a casket. We don't need that. That's okay. Okay, so we're just really trying to identify a couple of things. I think the first 3 things, you're like, yes, I get that. I totally got that. But then all of a sudden, when we came to the last 4, you're like, okay, I think I was right there with you with the domain, because you say it's going to be that all the time. But I think the last 3 kind of threw you for a little bit of a loop. All right? If I'm right, I know I'm right. So, I mean, I'm not conceited, but, I've been teaching this for a minute, and yeah, I get it. All right? So, let's go what we know. All right? Just by looking at it. Right? So, we have a parabola. It's opening upward. It opens up like a cup. I see a vertex, which is right here. What is that vertex? What is that point? Give me my order pair for this vertex. Go ahead and put it in the chat. What do you think? Remember, order pairs is your x value, comma, your y value. Okay. It's weird, like on my phone I can see comments, but on my computer I cannot. That's weird. Okay. but I do see 4, 1, 4, 1, 4, 1. Good. My x value is 4. My y value is 1. Okay. All right. So, do we have a max or a min? Melissa already knew what I was going to ask. All right. Yeah, I'm not seeing comments on my computer. Hold on. Maybe I might have to refresh a little bit. Yeah, I think I do have to refresh. Objects that are the same. Okay, there we go. Mama just had to refresh a little bit. Okay, that's rolling in, rolling in, rolling in. Okay. All right. So what is the max and what is the min? So maximum will be a high point. But right now, it's going at a low point. So since it's a low point, it is a minimum. It's still the vertex is the low. So since it's a low point, it is a minimum. It's still the vertex is the lowest point of all these other points that's on this parabola. Now, my axis of symmetry, it's a line that goes right through my vertex. All right? And it's always going to be x equals. But x equals what? Okay, am I still frozen? Oh, there we go. All right. Hey, Leanne. Oh, you're frozen? Am I frozen? I just refreshed. I might have to reset the room. Oh, I'm good now? Okay. Okay. All right. So it's going to be x equals 4 because it's going through the x of my vertex. That's going to be my axis of symmetry. Okay. So if they ever ask the axis of symmetry, you can figure out the vertex is, whatever the x value of the vertex is exactly as the axis of symmetry. So that means this side is equal to this side. My domain is always the same. All real numbers. Okay? All real numbers. Yes. From negative infinity to positive infinity. Yes. Now, my range, that's when I look at the y of my vertex. So I know I have y and I know there's a 1. But I need to look at my graph to figure out the inequality sign. Since it's opening up like a cup, that means it's dealing with my y's that are greater than. So this should be greater than. And since it's a solid line, it's greater than or equal to. So it'll be y is greater than or equal to 1. So when would the domain not be real? That's when you basically have an ellipse. When your parabola is like this. Okay, that's when it's not real. Okay. All right, so now, how many, oops, a little too far. How many x-intercepts do we see? So I know some people were saying, okay, no real x-intercepts, too complex. Good, VC, nice. Okay? So it's not crossing the x-axis at all. Hell, it's hovering over it. Okay? See, take a look right here. There's nothing. There's a huge little space right here. Okay? So it's not touching, it's not crossing the x-intercept, the x-axis at all. So that will be 0, goose egg, none. All right? How many y-intercepts? Now, right now, I don't see there's a y-intercept, but I bet you if I keep going, and it keeps spanning out, there would be a y-intercept because there is no restrictions right here for the y-intercepts. Okay, we can't see it, but I know as soon as we keep going, eventually it might even cross there. But right now, I can't even go by that. Okay. Okay, can't really even go by that. But really, it should be 1. I was like, I can't go by it. Yeah, it's going to be 1. Because eventually, it's going to keep going up, and out. So eventually, it will cross, especially when we deal with larger numbers. All right. Okay, 2 more. So we're just, I know at a later time we're going to work on the equations. I just want you to get just the premise. Okay. Yeah. So 1 y-intercept. Yes. Would that not be our real numbers? Right. Because if it's not crossing the x-axis pretty, you don't have any real numbers. And remember, complex solutions come in pairs. Okay, if you don't know what a complex number is, we're looking at that I value, the square root of -1. Right. Okay. Yes, this is my book that I sell. So I try to keep all my math books. This is just one of the other ones. It usually has like 100 pages where you can put all your notes and your informations in here, as well as, I'm going to get back to it, as well as if you're not strong with your multiplication, I do have factor sheets from 1 to 200. And then also some of the reminders, like the rules of integers. Then we also got our equation of the line. We got our standard forms. Hey, this looks familiar. Okay, we're going to be going into the quadratic form, I think, next time. But then we have the properties of exponents, order of operations, where we got into volume. So a lot of these things to help us refresh, and especially when you get into Algebra 2, I know you guys are going to have the unit circle. Algebra 2 and pre-calculus. And then I give you a section for some brain break. Sometimes you just need to help a little bit of refocus just to get you back on track. Yep. So this is available on Amazon. You can click on my profile and then go to my website. And I'm thinking about, because a couple of people keep asking me, Audrey, can I get copies of your notes? And I'm thinking about selling the copies of my notes, like literally for $1. Not $1 per page, but I would like say, let's say like my linear stuff. So slope, that might be different types of slope that I've done. That will be like one category. Or equation line, standard form, slope intercept form, that'll be grouped together. That'll be another one. So I'm thinking about doing that. So just be prepared. And then I still have to figure out this whole subscription thing that people will keep joining. And I'm like, oh, you need to join something. Good. Aw. Don't say you hate it. I think it's just because it's a lot. And usually you're going to get a person that's jamming it in your face because they're like, oh, wait, there's going to be a test on this. And that state assessment is right around the corner. So a lot of teachers are in panic mode right now. Yeah, trust me, I'm exhausted. And I still have to tutor in about less than 20 minutes. So anyway, all right. So, all right, thanks, Mel. Okay, so here we are. My vertex. Okay, what is my vertex? Tell me what my vertex is. Okay, we got 1, 2, 1, 2, 1, 2, 1, 2. What would you suggest me to do this study for the algebra honors? Oh gosh. I'm not sure where they go up to for the EOCs. I think they go up to system of equations. Definitely have to do exponent, system of equations. I think they do radicals, if I'm not mistaken. Is this in Florida? Pretty? What area? Okay. Right. Oh, I get this. So what state? Okay, yes. Oh, Florida, yeah. Aren't they thinking about getting rid of it? Wait, hold on. Aren't you guys thinking about getting rid of it this year? Why are you taking it? Because I have students in Florida, and they got rid of it. Or am I losing my mind? Yes, we are going to have a maximum because it's opening down like a frown. Okay, so we got the vertex as 1, 2. Yeah, you might want to double check with your guidance counselor because I don't think they're doing that anymore. Okay, axis of symmetry. What is it? X equals what? I didn't see those being flashed around. Good. Hey, Rose. Lovely to see you again. Amazing kid. Good. Gay environmentalist. Welcome in. Yes. Oh, Misadventure. When'd you sneak in here? Yes. So x equals 1. Good. Wait. So if it opens down, it's always a maximum? Yep. Opens up, it's always a minimum. There you go. Yep. All right. So the axis of symmetry. Whoa, whoa, whoa. Whoa, whoa, whoa. Hold on. Hold on. Wait a second. Who did this? I think it's Luciano. Okay, your max. I think it's Luciano. Oh, where'd it go? Your axis of symmetry is not 2. Your axis of symmetry goes through your x-axis, not your y-axis. So the AOS is actually going to be at 1. Okay? Last time I checked, just the people I have are outside of Miami. Was it bringing? No. What is it? Broward? I think it's Broward County. I think that's what it is. I sent the message. Okay. All right. Perfect. Yeah, I was like, Luciano, do not do that. I'm going to test about this tomorrow. I'm definitely watching this. Awesome. All right. So my domain. The trick is the domain is always all real numbers. Regardless, if you have a parabola, what we're looking at is a small snapshot. Eventually, it's going to expand out and out and out and out and out. We're only seeing one part of it. So it's all real numbers, or as some people like to say, from negative infinity to positive infinity. All right? Now, let your vertex help you find your range, because my vertex helped me find the axis of symmetry. Okay, the x value of your vertex is your axis of symmetry. So your y value of your vertex is going to help you with your range. But what goes in between is based off of the parabola. The parabola is opening down like a frown, right? So it's looking at numbers less than, but not just less than. There we go. Versus says it, less than or equal to, because it is a solid graph. Okay, it's a solid red line. It's not dashed. So it's including that point at 2. Okay? All right? Point at 2. Okay? All right? And it's going down, so it's going all the way down to negative infinity. So that means if it's going all the way from negative infinity, I think it was angle. I saw it really quickly. If it's going all the way from negative infinity, I think it was angle. I saw it really quickly. Make sure if you guys are putting it into intercept form, interval notation, the smallest number always comes first. So the smallest number is negative infinity, and then 2. Infinities, negative or positive, always gets a parenthesis. But since it's equal to 2, it's including that 2, we're putting a bracket. Okay? Okay? So the vertex is your highest point. It's your turning point. Okay? Just like parts of my life. Before divorce, okay, it was all right. And then everything just went south. Right? So it got to a point where it changed. Okay? There was a change. Your changing point or your turning point is called your vertex. So my x value is 1. My y value is 2. That's where that vertex came from. 1, 2. To find the axis of symmetry, it's always going through the x-axis. Notice it doesn't even touch the y-axis at all. Okay? But it goes through the x-axis. So you have axis of symmetry, which is x equals 1. Right? Since it is a frown going down, this is your highest point. That's why it's called a maximum. Okay? Do you do this? I should stress about it. It's a credit class. Okay. Okay. So it's basically your final, not the state assessment. Okay. All right. Let me scroll up. How would it be a minimum? So Brooklyn, it'll be a minimum if the graph is open up like a cup. Then it would be your lowest point. That's how it's a minimum. If it's opening up like a cup, you got a minimum. If it's opening down like a frown, you have a maximum. Okay. Oops. All right. All right, good. Wait up. Okay. All right, so we have all of that. Your axis of symmetry, axes mean line that goes through that vertex. So it only goes through the x. To find your range, you're looking at your vertex. You're looking at the y value of your range. You write your y and your 2. Then you look at the graph. If it's opening down, it's going to be less than. And it's a solid graph. It's not dashed. So it'll be less than or equal to. So now, how many intercepts do I have? How many x-intercepts? It's crossing the x-axis here and here. So it has two real x-intercepts. And then does it have a y-intercept? Yes, it does. And it's crossing right here. That's your y-intercept because it's intercepting the y-axis. So how many do you have? You have one. Okay, good. The domain is always all real numbers. Yep, from infinity to infinity, no matter what. Because what happens, it's going to keep going out. It's going to keep expanding out, expanding out, expanding out as it continues on. We're only seeing just a small snapshot of it. Okay. All right, thank you, Cam. So yeah, it's at negative 0.5 and 2.5, and the one y-intercept is at 0, 1. Good. All right. So how do you find the vertex without the graph? You will have to use your formula, which I'm not doing that tonight, but you have your x equals negative b over 2a. So once you get your equation, you find out what your x is. Then you take that answer, plug it back into the original equation to find your y. Okay. Okay. So, all right. The vertex. Yeah. Oh, Emmanuel. Hello. All right. Okay. One more. Okay. Got like 5 minutes before I have to go back to tutoring. Okay. Yeah, I tutor at this crazy time of night because I have people in California. So, vertex. Zoom in. What's my vertex? Do I have a maximum or min? And give me my axis of symmetry and my domain. So we'll hold to the last 4 in a second. Let me do this. Okay, give me my vertex. Do I have a max or a min? What's my axis of symmetry and my domain? Okay. All right. I'm like a proud mama right now. About to tear up. Look at all these beautiful answers. Jesus. There's 106 people in here. Good job. Okay. All right. So, love it. So while you guys are here, tap away. Okay. All real numbers. Good, Leanne. Spill. What grade is this for? Well, this is like Algebra 1. Okay. Lovely. Good, Jordan. Domains all real. Yes, we have a maximum with that. She forgot all of this. That's fine. Can always come, bring it back. Ooh, thank you in Spanish. All right. All right, vertex. Vertex is right here at the turning point. Turning point is at -4. The y value is 3. So since it's opening down like a frown, we have a maximum point because it's the highest point of the graph. There's nothing above it, but there's tons of stuff below it. Axis of symmetry. That means I'm going to the x of my vertex. So if my x is equal to -4. So if I drew a line, that's what axes mean. And we're going to pretend that line was straight. Okay, we're going to draw that line through my x-axis. It's not crossing the y-axis at all. It's only going through the x-axis at -4. And then my domain is all real numbers, which means from -infinity to +infinity. Now, my range, okay? It's my y's, my range. What do you think my range is going to be? Okay? So how you can tell it's a max or a min, it's how it's shaped. If it's opening down like a frown, it's a maximum. If it's opening up like a cup, it's a minimum. Well, thank you, Leah. All right. Because it's at the bottom, right. All right. Okay. So I got a couple of things. Negative infinity to 3. Range is at 3. Can you show the range in the form? Yep, you can show it in the form of the inequalities. Yes, you can. So, since I go to my vertex, this helps me out so much. I look at the y value of the vertex. That's a 3. So that means the y value of my range is going to be at 3. That's the highest point, right? It's at the 3. But it's dealing with numbers that are less than 3. So we got a less than. But since it is a solid red graph for the parabola, it's including that 3. So it's less than or equal to 3. So since it's dealing with numbers all the way down to negative infinity, I have to put my lowest point first. So negative infinity to 3. Remember, the infinity or negative infinity always have parentheses, but the 3, since it's included, will have the bracket. Okay. X-axis is 2. X-axis is negative 4. Yeah, the y-axis is right here. Or are you talking about the x-intercepts? Why do you put the infinity first? I put the negative, Julia. The negative infinity is the lowest number. Anytime you do interval notation, you always put the lowest number first. Okay. Okay. All right. So now we have how many x-intercepts? How many places does it cross the x-axis? It crosses the x-axis in 2 spots. Okay, how many y-intercepts? Remember, we're only seeing a small section of this. So if it keeps going, it keeps growing, it keeps growing, it keeps growing. So there will be 1 y-intercept. And if you haven't noticed, every time we did this, boom, there was 1 y-intercept. Boom, there was 1 y-intercept. Boom, there was 1 y-intercept. So could we say every time you see a quadratic, you're always going to have a y-intercept? Okay? Basically, okay? Unless there's some kind of restriction. But you basically will have a y-intercept, but your x-intercepts may vary. Here we had 1 because it hit the x-axis at 1 spot. Here we didn't have any because they're complex. It doesn't cross the x-axis at all. Here we had 2 because it crossed the x-axis at 2 spots. And then here we had 2. Okay, my person's running late. Good. All right, that's good for us. Here we had 2 because it crossed the x-axis at 2 spots. When will you be teaching this again? I know I'm going to be expanding on it because I want to work on finding the equation and put it in vertex form. So I was thinking, because next time I go live is at 1 p.m. So I don't know if I'll be able to on Thursday. That's kind of up in the air depending on that one kid. But I will try to be here Thursday night. If not, I'll be here Saturday. Okay? On the way with the parentheses and brackets. What do you mean, Julia? Can I write the range in the other way? So are you trying to say, can I write 3 comma negative infinity? All right. All right, Lisa, take care. Thank you so much for coming in. Greatly appreciate that. Okay. So anytime it's an equal to, you always put a bracket. When it's including, you put a bracket. Parentheses always go with the infinity symbol. Okay. Well, thank you for the follow. Is there a formula sheet? I do not have a formula sheet, but I can make one. Okay. Oh, thanks, Bridget, for helping people out. Okay. Can I do one more, please? I would love to, but I need to get ready for my tutoring. Okay. So how do you know the range? The range is your y. It's the set of your y's. So if you know what your y value of your vertex is, you know the y value of your range. All about this. I know, right? How do you get y less than? Okay. So the reason why it's less than, because it's using all the lower y values. Anytime it's opening down, you're going to get less than. If it's opening up, you're going to get greater than. Yep. There you go, pickle. All right. Okay, so what I'm going to try to do while I am tutoring, because I got to go and do that, I am going to put all this information onto my YouTube channel. So if you do not know about my YouTube channel, I usually put all of my live recordings on there. So it's under Audrey Codner ACG Math Tutoring. So if you want to take a quick little print or screenshot of it, you can go ahead and subscribe to my YouTube channel, Audrey Codner ACG Math Tutoring. All of my lives are going to go on there, and soon enough, you guys are going to get access to be able to purchase all of my notes. So the Audrey notes. Okay, do I do geometry work? I do geometry tutoring, but I have not done any geometry on my lives just as yet. I just started with the lives like in February, so there's a lot of algebra that I have to do. Okay. All right. Well, thank you so much for the likes. I appreciate it. I appreciate everyone's in here. Wow, 67. Good job. Thanks for spreading the word, guys. And I will be live again tomorrow at 1 p.m. and also Thursday at 1 p.m. But I will try to get live later on Saturdays. But usually my Tuesdays is when I'm going to be able to come on at 8:30. And I might be able to sneak one in on Mondays as well. All right. So if you always need a private tutor, I'm more than willing to help. If you have questions, go ahead and just DM me and we can take it from there. Right? Is there always going to be one? Yes. Even for a complex, yes. There's always going to be one y-intercept. There won't be no real x-intercepts, but there will always be one y-intercept. Okay, I'm trying to see, show us how to find the endpoints of graph. To have the midpoint. Not tonight. So much. Not a problem. Okay, so just be on the lookout. It may take me a couple hours for me to upload it on there, but it will be uploaded hopefully before midnight Eastern Standard Time. That's the goal. That's the goal. Okay, so I'm Eastern Standard Time. So right now it is 10:35, and my person is here. All right, guys. Sorry I had to cut this short, but I will be live again. Go ahead and follow me, and then I will see you guys on YouTube. All right, take care. Have a lovely evening.